Okay, so we're going to take this function, we're going to graph it. So the first thing I want you to do is I want you to go through the position function and just look at and see what you can figure out from it. So pause the video now and go figure that out. Okay, so here's what I'm going to be looking for. I'm going to look for any x-intercepts. I'm going to look for n behaviors. I would normally go look for vertical asymptotes and horizontal asymptotes, but this function doesn't have it. It's not a fraction. So let's see what we got here. So I know there are, if I factor this thing, I get, that's a terrible equal sign. Where's my erase? There it is. So when I factor this, I get this. And setting that equal to 0, I see that there are x-intercepts when x equals 0 and when x equals -4. That's nice. And what else do I know? Well, I know that as I plug in, as this function goes out to positive infinity, so as our function as x goes out to positive infinity, right? The function goes to positive infinity, and you can confirm this by, ooh, that's terrible. I don't want it to look like that. That's super messy. So as I plug in really large positive numbers, it goes out to positive infinity. As I plug in really large negative numbers, right? As this thing goes out to negative infinity, there. As it goes out to negative infinity, it's also going to be positive. And again, go confirm this. Don't just believe me. Confirm it for yourself if you don't see it. Okay, so let's see what we got so far. And if you don't mind, well, okay, so let's go see what we have so far. So I'm going to plot what I have. So I have my negative and positive and my n behaviors kind of, right? And then I have an x-intercept at 0, 0, and I have another one at 0, -4. Okay, perfect, perfect, perfect. Time. I think we got all we can figure out from the position function. Let's go look at the first derivative. So going to our first derivative, so I get y prime equals 4x cubed plus 12x squared. Is that correct? That is correct. So let's go find our critical values. So I want you to pause your video. Here's what I want you to do right now. I want you to pause the video. I want you to find your critical values. I want you to plot those points on your coordinate grid, and I want you to make a guess as to what is going on. Okay? Go do that now. Pause. Okay. Hopefully you've done that. I'm going to go do it again, and if you were having any trouble with any of those pieces, we'll fix it now. So I'm going to find the critical values by setting the function, the derivative function, equal to 0. So in doing that, I get this. So I see that critical values are when x equals 0 and x equals -3. So in other words, those points, right, I want to know what those points are, so I'm going to go plot those points in just a second. So in order to find them, I'm going to have to evaluate the original function at y equals 0 and y equals, sorry, I keep on saying y equals, x equals 0, x equals -3. So let's go and do that. So we already happen to know x equals 0. That was a point that we plotted. We know it goes through 0, 0. So that's just 0. And for this one, we plug it in, again, plugging into original function, I get -27. So what does that tell me? Well, that tells me that there's a horizontal tangent, and let's do this in yellow. There's a horizontal tangent to the graph at 0, 0, and you can see, hopefully see that at my 0, 0 point, and that at, what was it, -3, -27 down here, by the way, not drawn to scale, right? Definitely not drawn to scale. There's another horizontal tangent. So I'm ready to kind of go through and make a guess. Let's go and do that. Let's go and make a guess right now. And I'm going to make a guess in light pink. How about? So here is my guess. My guess is that from -infinity all the way down to here, it's decreasing. Then it gets to, what was that, -3, and then it goes back up. And it flattens out for a second, right? There's a horizontal tangent right there, and then it shoots back up again. So this is my guess. From here on out, I am going to be confirming my guess, right? This is that's my graph, and I'm going to confirm it. So let's go through and do the things that we're going to confirm. And again, you do need to confirm it. You do need to go make your sign chart and confirm. But this is going to help us out a lot. It's going to, one, if my sign chart disagrees with my graph, that tells me the graph is wrong or the sign chart's wrong, right? Probably, honestly though, if it disagrees, it's probably my sign chart. But let's just find out. So let's go make our sign chart for this thing. So for our sign chart, we are going to, so this is the sign chart for our derivative function. We're going to look at our critical values. Our critical values were 0 and, whoops, they are -3 and 0. Let's do them in order, shall we? So -3 and 0. Let's go make our sign chart. So I plug in numbers to the left of -3, like -100. Well, that's obviously positive. Between -3 and 0, I plug in like a number like -1. Oops. Let's go back. I am sorry. My apologies. Let's go back. I was plugging into the original function, so I need to plug it into here. Let's do that. So I plug in like -3, like -4, -5, -6, -100. It is very, very negative. Good. I plug in between -3 and 0, I plug in like -1. This is very positive. And then from to the right of 0, it is again really positive. So what does this tell me? Well, this tells me, and let's see, this tells me, and I'm just going to do this in a nice little orange color. It tells me from -infinity to -3, this thing is going down. And then from -3 on out, it is going up, right? That's what this graph is telling me so far. So, right, we should have, according to our sign chart now, I'm just looking at our sign chart, we should have a minimum at -3. And guess what? Right there at -3, at the point -3, -27, we have a minimum value. So that's correct. Our graph for that is correct. And then at 0, 0, right, at this point right here, we should have a stall point, which we do. It's not perfect. Mine's not perfect, but there's a stall point there. Okay, so it's time to move on. So so far our graph looks really solid. I want to go look at the second derivative, because here's what I'm saying. According to my graph, I'm saying this thing's concave up the entire time. And I actually don't know that. I really don't. I know, here's some things I do know. I am pretty certain that this thing is concave up at the minimum value. In fact, I know that. I know that it's concave up at the minimum value. So there's just no other way that could work. It would have to be not differentiable for it not to be concave up there. So, but other than that, yeah, there's some things I don't know. I don't really know the rest of the concavity through here. So let's go check our concavity to see how I did. So I feel like my guess is pretty good, but I definitely could be wrong. So time to go take the second derivative and find inflection points. So my second derivative is 12x squared plus 24x. And finding inflection points, right? So I have inflection points, take the second derivative set equal to 0, factor, and I get x plus 2, which means our inflection points at 0 and -2. So my graph is actually, just based on this, I know that my graph wasn't perfect. And let's find out why. Because according to this, there should be some inflection points on my graph, and I don't have any. My graph is completely concave up, so I need to deal with those inflection points. So we're going to plot our inflection points. So 0, 0, which we happen to have already plotted, is not only a critical value, but it is also an inflection point. Okay? So it is an inflection point there. And then -2, so when x equals -2, and what is that? I haven't calculated that. So I get 16 minus 32, so -16. So at -2, -16, I'm going to say that's right here. There's another inflection point. So I'm going to go and see what this looks like. So here's my guess. Okay, so I'm going to make my guess, and then I'll go and check I'll make a a sign chart for my second derivative, but here's my guess. My guess is that my left-hand side, well, first thing is I absolutely know, this is a fact at this point. Since there are no there are no inflection points all the way up to, before -2, this is concave up. I know that now. I just know this. That's absolutely right. What I now know, though, is that after -2, the concavity changes. So if it was concave up there, it should now be concave down. So in other words, I should, at -2, I should have something that looks like this, right? The concavity should change there. And then at 0, it's going to change again. It's going to go concave up. So that now is my graph. So let's go and see if that is correct. So let's go make a sign chart for our second derivative. But like I said, I am so certain that I'm right. But let's go check. So 0 and -2 are our values. So -2, 0, and this is for our second derivative. Now remember, I'm plugging numbers into this function. So let's go to the left of -2. So numbers like -100, well, that's obviously positive. Between -2 and 0, well, if I plug in numbers like -1, it is negative. And to the right of 0, it's positive. So what does that tell me? It tells me from -infinity to -2, so from -infinity, I'm going to do this, I'm going to just trace it in yellow. So from -infinity all the way to -2, that yellow part, that should be concave up. It is. From, let's do this in orange, from again, these are x values, from -2 to 0, it should be concave down, which it is. And then finally, I'll do it in yellow one more time. From 0 to infinity, it should be concave up. Perfect.